All right. Okay. So let's finish the last slide of chapter 8. So the last time we talked about bad sampling and good sampling, right? So bad one is what? How many types we have here? We have the two bad sampling, which is convenient sample or voluntary response sample, and three of the bias, how surveys can go wrong, right? So it could you could have selection bias, you could have non-response bias, or response bias. I suggest for the exam, go through my slide here, these two slides, and try to understand them good, okay? Because I'm not, well, on the exam, I'm not going to ask you the definition of what is non-response bias, what is selection bias, but I'm going to give you a scenario where you choose, where you do multiple choice, right? Which pick one, just the selection bias, non-response bias, or response bias. Okay, so the good sampling method is simple random sample. There are goods 1, 2. The other one will be stratify random sample. Stratify random sample is when first you classify the population into groups of similar individuals. And then they'll call each of those group called stratum, plural is strata, right? So then choose a separate simple random sample in each of stratum and combine the simple random sample to form a full sample. So let me give you an example. Say I have a population bubble. That's my population bubble. It have children, it has teenager, adult, and senior. So I have four groups of people in here, right? A bunch of people in here. Now, because they all have a different physiology, right? Children, they have, say, heartbeat. So children heartbeat is different than teen, different than adult, different than senior, right? So what I'm going to do is I'm going to stratify this population first. So I'm going to say here is my population of all of the children. Here's the population of, oops. The second one will be population of teen, right? So it's teen. I'll say children here. Children. And then I have adult. Maybe senior. Adult, like middle age. I'll just put adult and senior together because they are adults. So I have three. Those are called strata, right? So each of these called stratum. Stratum 1, stratum 2, stratum 3, right? So what I'm going to do is from each stratum, I'm going to pick a few of the children, a few of teenager, and few of the adult. And then I'm going to combine those together into one sample. Okay. Maybe it's not this example, say children, teen, adult. Maybe it's a better example here, down here. Right? So here it's the same, say university have a lot of freshmen, have a lot of sophomore, a lot of junior, and a lot of seniors, right? So I want a survey 100 students. So, and then for each of those, I'm gonna have a freshman group, sophomore, junior, and senior. So what I do is in a freshman stratum, right? Everybody in freshman stratum, I'm gonna choose 25, and randomly choose 25 students. In sophomore stratum, I'm gonna randomly choose another 25 sophomore and junior and senior. And then I combine them all, I got 100 students for my sample. Does that make sense? So that's stratify. That's stratify random sample. Okay, so that's it. That's for chapter 8 is done. Now,
I have a question. So for the chapter 8 homework, I started it and there's some that I didn't know how to do because you have to use table B, they're saying, which is the random digits.
I thought I
no,
deleted
there's like 3 questions about it.
You don't do though. I'm gonna, remember what number it is? Oh, they don't have.
Yeah, it's number 9, number 10, I think, and number 27.
9. I'm gonna delete them. I don't teach them. 9 was 9. Who use those anymore? You have calculator. 9, 10?
Actually, I think it's just 9 and 10, maybe.
Oh, okay. If anybody see more, as use table B, let me know. I'm gonna delete that question, okay?
I think there was also two more at the bottom that were like along those lines where it wanted you to assign and then use the table. I think they were around like 20.
I can look real quick.
Yeah,
I have
question
it up.
20.
Oh, okay.
Yeah.
Or 9, 10,
Oh yeah,
11.
question 22 is like that.
I'll delete them. I'm gonna delete them. Thank you for letting me know.
Okay, and if we did the rest of them, it's not gonna affect the other questions we did, right?
No. Mhm.
Professor.
Mhm.
For the ones that are like written for like chapter 2, 3, and even like chapter 8, if
Mhm.
we think we have the right answer, but like it didn't correct it because like we might have like added some more typing that like they didn't expect, would you go back and like fix or look at that and then grade it, or?
No, it's too much work for me. What is it? What happened? Why is it you don't have a correct answer?
Yeah, so for chapter 3 and 8, it said it was correct, but chapter 2, I think I have the correct answer. Like I answered it correctly, but it said it was like incorrect, and
Incorrect.
I was assuming it was just because like maybe I like typed too many things, or because I like typed it out in sentences like when they wanted you to explain.
Are you talking about the last question is the free response? Is that what you say?
Yeah.
Oh, that one, the grader is graded for you. I don't grade them, but I have a grader. I give her the solution. So maybe you're missing something. I'm gonna make the solution available. I have it here, and you cannot see it. Let me show you. I'll show everything here. Share. You guys got kicked out or something and people keep coming in. I'll make it available. I don't know when chapter 8 due. When is it due?
26.
Oh, okay. So here, chapter 2 and chapter 3 homework, I'm gonna make it right now. It's hide it from you, right? Chapter 8. Do I have any free response in chapter 8?
Yeah, there is.
But
Hmm?
at the end, but like
Oh, okay. So then I'll put the solution there as well, and I'll make it available for you. And you can
Okay.
see what you did wrong. Does that make sense?
yeah,
I
if
cannot come
we-
back and grade it. That's why I have a grader for, right? I don't want to grade it.
I was just wondering because it like automatically graded it. Like,
No, it's
so
automatically graded, but then she come back and she fix it.
oh, okay.
Yeah, she come back. It'll give you 100%. Whatever you say, that just say I'm happy. Even you say I'm happy, it'll give you 100%. It doesn't. It's called free response. But she come back and she regrade it for you. Mhm. Anything else?
Before you go over the practice test answers, I just had a question about like the old content, like chapter 3 that's on the quiz today.
Mhm.
So how do you know, like, unless it says, how do you know if you're supposed to put the probability in like just the 4 digits or in a percent? Will it always tell us or?
No, it won't tell you, and I don't tell you, but you always do four decimal.
So
for the
like
probability. Mhm.
if it was like 0.0359, would I put that from the Z table or like the Z score, or should I put 3.59%? You know what I mean? For the probability.
3.59. They're only 2 decimal.
Yeah, but like I'm asking, so like, you know how when you go to the Z score on the table and it's like a 4 decimal number?
Mhm. Yeah, you're supposed to write that down.
Yeah, so do you like in some of the homework problems, it asked us to put it as those 4 digits, and in some of them, it asked us to put it as a percent from what I
Okay.
remember. So would it tell us in the quizzes like, oh, the like
No.
put it in a percent?
I have the quiz. I have the answer for you, and you pick the best option.
Okay.
Mhm. Yeah. All right. Let me go back to anything else before I I start the exam review.
Are you
Oh.
gonna have office hours on Thursday?
Say it again.
Would you have office hours on Thursday morning before the exam, or is it?
Before the exam, you have to tell me the first though. So a lot of time people don't come and just sit there waiting for you guys. So don't be there. But out Thursday, if you want to see me, I'll be there, 10:30 to 11. If you want to come and ask me a question.
Okay, thank you.
Yeah. See exam 1. I should ready to finish your exam today. All right. Okay, let's go to the first one. First one should be easy. I want everybody to get the first one right. So just when I ask something, just answer out loud, okay? I don't have time to go back and check in the box. If you got the right answer, then you got the bonus point check mark. The first one, smoker, categorical or quantitative?
Categorical.
Good. You know what? Let's not do. I'll give you the chance to do bonus point check mark later, but let's not do it today. I want to be fair because other people want to say it too. I'm sure they know the answer, but they didn't say it. So let's not do the bonus point check mark too for the exam review. Okay. This is for your benefit. You should answer me anyway. All right. A number of visits to emergency room in the past year.
Quantitative.
Thank you. Body temperature.
Quantitative.
Thank you very much. And age group.
Categorical.
Very good. Very good. I know it could be misleading because they're numbers, but they're being categorized, right? They're being categorized. Okay, so here's the bar plots. I have double bar plots here. It's the blood pressure group by study. The participant was assigned to one of the 2 medical studies. Study A has 20 participants. If I was you, I would highlight some stuff. Study A is, I'll highlight in yellow, 20 participants. And study B had 20 participants as well. Systolic blood pressure measured in millimeter. No, milliliter. Yeah, milliliter of mercury was measured for each participant and compared across the 2 medical studies. The side-by-side plot is present below. All right, the first one, the person with the lowest blood pressure in study A has the blood pressure of blank. The person with the lowest blood pressure in study A. The lowest blood pressure in study A.
80.
Yeah, 80, right? 80. 80. So they just say the lowest, so just pick the smallest in the smallest value in the data set. So 80 milliliter. Milliliter. About 70% of participants in study B have the blood pressure higher blank. About 75% of people in study B have the blood pressure blank higher.
125.
110.
Yeah, 110, right? Says what? 75% of participants in study B have blood pressure higher, right? So higher is what? So 75% is from here to here, right? And why do I choose this but not this? Here, I'll use in black. Why do I choose the red part but not this part? Why that's wrong? You say, Mimi, that's 75%. But we want what? We want 75% what?
Above.
Yeah, higher. They say higher, right? They say higher, not 75% quartile, right? So 75% higher. So from highest to up to 70%, 75% is 110. Do you have any questions so far? Please ask if you have questions. Otherwise, on the exam, you're gonna have something like this on the exam. Of course, the wording is not gonna be exact. I can change a little bit. I can change instead of say about 75% of participants in study B have high blood pressure, higher than, I can say at least, right? I can say at most, or whatever, right? I can change a little bit and the answer will be different. But as long as you understand what you do in here, you okay. You should always have the right answer whatever question I come up with. If none of the participants in study A has blood pressure of 140 milliliter of mercury, how many of the participants in study A had blood pressure of at least 140 milliliter of mercury? At least 140. So at least 140 is where? At least 140 is right here, right? Some from 140 up, because 100 at least 140. Now what do they asking? They asking how many participants? They asking for people. How many people in study A that have at least of the blood pressure 140? So how many percent from?
5.
Any suggestion? How do you come up with 5?
It's 25% of
And
the 20 participants.
very good, right? Very good. That's why I highlight the number 4, right? So 25% of the 20 participants. So, so 5, right? 5. So 20 times 0.25 equal 5 people. Very good. Does anyone have a question about the last one? Open up something okay. All right. Number 2 is again different problem now. I have 11 observation of IQ score. First question, I want you to draw a stem plot. So before you draw, I suggest that you reorder. Okay, just reorder here. So here I'll say order. Order is what? From lower to small. What's the smallest? 82.
82.
Yeah, thank you. I have hard time looking at close stuff. I can see it just all numbers just kind of run around. 82, 93. I'm gonna cross it out so I can know. 93, 95, 96. Is there any more 90s? 100, 102. 104, 109, what else? 112, 114, 119, and 124. All right, all right. Now we draw a stem plot. By the way, you have 2 parts, the stem part and the leaf part. The leaf part always one digit. I think I said it backward before when I was lecturing, but let me say it again. I fixed it, but let me say it again. The leaf part always 1 digit. You can have many digits on the stem part if you want. When this problem is easy, it's only 2 digits. So let's see So A, 9, 10, 11. That's it, right? 8, 9, 10, 11. 8, 9, 10, 11. Oh, 12. For the digit so here we have the maximum is 3 digits, right? Anything above 100 is 3 digits. So for the one that don't have the 2 digits on the stem part, you want to put 0 next to it. So I'll put 0 here, 0 here, just to make it, uniform. 08, 09, 10. So they all have 2 digits. And then what? 82. I got 82, 93, 95, 96, 102. So 102, 102, 104, 109. By the way, on the exam, I want you to. You have one like this on the exam. I want you to put the number on the same column. Try to as best. Okay, I know it's not perfect, but try to be neat. So when you draw a distribution, you draw a density curve, You know what shape it is. 11, 12, 112, 114, 119, and 124. And now if I draw my density curve, wow, it's like a perfect normal density curve, right? So is the normal is a bell shape. So what do you say? Describe the overall shape of the distribution. Make sure you include the context. That's part of your grade. If you just say something, I'll subtract 2 point off because if you don't include the context, well, you gotta include the context. So I know what you're talking about, right? Or non-specific people know what you're talking about. Okay, so what do I say? Someone tell me. So sock, right? Remember socks, shape, outlier, center, spread. Someone
Say the following observations for IQ scores follows a unimodal normal distribution with a center of 104 IQ and ranging from 82 to 124. And I would put in parentheses 42 for the range. And then
42 or 124, right? Oh, you will mean subtract? Oh,
yeah. What would you prefer? Would you prefer us to do?
I prefer just the range for smallest to largest. You don't have to give me the difference, but it's okay. I'm not gonna take point off.
Okay, and then I said no outliers.
Okay, very good. Yeah, the distribution, very good. It's all. It's. I think that's it. Oh, one more thing. You missing one more thing. Unimodal. Did you say unimodal?
Yeah, I did.
Oh, okay, good. Then you're good. The distribution of, now come to context. The distribution of what? Of the IQ score. Is unimodal and has a bell shape. With too close to this letter, with no apparent or potential apparent outlier. Well, the center is about, what the center is about, what do you think?
104.
Yeah, you can pick the median. You can pick the median for center. It's about 104, right? On the exam, just pick the median for your center. Okay. If it right skew or left skew, it's harder for you to eyeball, but once you rearrange the number, you can just pick the median. It's about 104. What 104 score? Just don't just say 104. 104 score, and the range is from 82 to 124 IQ score. So that's what I'm looking for on the exam. You have exactly, well, not exactly, but it's very similar, something like this on the exam. I'll tell you before. I'll ask you to draw.
Can you repeat what SOC stands for again, please?
Oh, SOC is, can someone tell me what SOC is?
Shape, outlier, center, and spread.
Yeah, thank you.
Thank you.
It's on my lecture. All right, the 5-number summary. Before we do the 5-number summary, we have to order, which we did. We did we ordered from smaller to largest. I'm just gonna copy it down there because I don't feel like rewriting it. Okay, so they have 13. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's good. 11 data points. So well, first of all, the minimum What's your minimum? That's your min, right? And this is your max. What's the median? 104.
104.
Yeah, thank you. That's Q2. You can say median, but Q2 is shorter. What's Q1?
I got 95.5.
Hmm?
I got 95.5, but because it was between two of them.
Mhm. So the median is you cut this in half here. So let's see, I have, you don't have to write this part down. So 1, 2, 3, 4, 5, 6, right? So the middle two. So the middle two, this corresponds to the two. And so that will be 95 plus 96 divided by 2. 95 plus 96 divided by 2. What does it equal? 95.5. 5.5. So that's Q1. Q1. Q2, maybe write Q1. Make it a little nicer. I'm sorry, Q3. Q3. Same, right? Same. So 2. Average, so 2 Q3 equal 90. Oh, sorry, 112 plus 114 equal divided by 2. 113, right? Thank you. Okay, so that's your answer me for the that's 5.5 number summary. And then now we draw a bar class. The reason we need the in order to draw a bar class, you need the 5 number summary. Thank you, Fatima.
I have a quick question.
Mhm.
So let's say after finding all these out, and then like if we're drawing a box plot just to double check everything, if we
Mhm.
want to see if we have outliers,
Mhm.
and then we end up seeing that we do have an outlier, right?
How do we check the outlier?
We just take the what's it called, the interquartile range plus 1.5. No, sorry, the average plus 1.5
No, average.
times
No,
IQR.
no average, no average.
Oh, sorry, yeah, you're right. Okay, minimum minus
No, not minimum.
1.5.
Isn't it just the
Q1.
IQR times 1.5?
No, that's no. The formula is. Oh, hang on. Yeah, pull up your formula. Let me turn on the light again. What's the formula? Oh, checking the outlier.
Isn't it Q3 minus Q1, or is it Q1 minus 1.5 times IQR?
Yeah.
Oh yeah, it's that one.
Because you have to do Q1 minus 1.5 times IQR, and then Q3 plus 1.5 times IQR.
Yeah, that's it. So that's the allowance range. Remember that? So So first of all, I had to count what's IQR. IQR is what?
Q3 minus Q1.
Which is 113 minus 95.5, 17.5. Once you have that, you can do Q1 minus 1.5 times IQR, which is what? Which is Q1 is 95.5 minus 1.5 times 17.5. $69.25. And then Q3 plus 1.5 times IQR. You plug it in, so Q3 is 113 plus 1.5 times 17.5. I got 139.25. So
So
those
let's
are
say
your
hypothetically, like we end up finding out that let's say the maximum instead of 124, it was 150. does that mean, I know that on the box plot, we have to, we have to identify that, but then when it comes to the 5-number summary, we have to not include that. Does that change what the median is? Do we
No.
disregard that? No, we don't, we consider it as well?
No, we check for outlier. This one, check for outlier. So you're looking at the minimum and the maximum. So what the minimum here? Minimum is what? In the data set is 82, right? 82 score. Yeah. The maximum is 124. Well, you allowed to have what? You allowed to go from 69.5 to 139.25. So you're okay. You inside that range. Does that make sense?
Yeah.
Yeah. So you're good. There's no outlier. You inside the range. So 82 to 124 inside 69, 139. So you're okay. So it's 82. See, the reality is 82 to 124. And so you're okay. So you're okay.
I have a question. So if the max was like, so the original maximum from the 5-number summary, if that was considered an outlier after doing the IQR formulas, would that change your maximum in the 5-number summary?
Yeah. So the maximum is going to be the one right next to the outlier, I guess.
Okay, thank you.
Yeah, the one that so okay, don't write this down. Don't write. Let's say imagine I do IQR and I say my maximum is say 115. Say from 69 to 115. That's my allowance. So if you look at the data, you got 82, which is okay, but 124. But what's outside? What's above 115? What?
119
and what?
and 124.
So these guys, that's your outliers, your little dot that you put above the little line. Does that make sense? And then your maximum now is going to become 114. That's your maximum. Okay, that's your maximum.
Did you say 114 becomes the maximum?
Mm-hmm.
Oh, okay.
And we would change that in the 5-number summary in our like answer if that were to happen.
No. If there's outliers, say if they're outliers, don't write this down, okay? Because it's not your problem. But don't write, if there's outliers, say the 119 and 124,
So it only shows in the box plot, but not in the 5-number summary.
let me draw this box plots first, and I'll show you what happened if you have outliers. Does that make sense?
Okay.
Yeah, let me draw it first, and then because once I have a box plots, I can actually talk better. So let's draw the box plots, and I'll tell you what happened if you have the outlier. I'll give you more space on the exam. This is a lot. Okay, so let's say so I'm gonna start in 80 and then go 85, go 90, go 95, go 100, 105. You know what? I'm not gonna do 105. This is too much. I'll do differently. $80 and then 90. 100. 110. 120. Okay, that's better. All right, so first of all, the step for drawing box plots is what? You start with the Q1 and Q3, right? Q1 is 93. 93, 93, 93, 93 right here. So it's 95, so 93 a little bit below. I'm sorry, 95.5, my bad, 95.5, 95.5. roughly here. Okay, I'll use green. And then the Q3 is 113. You don't have to wait for me. It's 110, 115 right here. So 113 right here. Then I'm going to draw a box. Okay, so that's Q1, Q3, and then now the median. The median is 104. Sorry. 104, 105 right here, 104 a little bit below. I'll use red. Oops. My ruler. By the way, on the exam, I suggest you have ruler with you. Or use credit card or student ID, whatever is something you can draw. Okay, that's median. And now the min and the max, right? The min and the max, 90, 82 here. And then 124. Then you're not done here. You have to remember what you have to do. What's the last step? Don't forget the title of your graph, right? So yeah, there will be space for you to say something, but on top of the graph, you say, I'll say, I'll put right here. Bar plus of IQ score by you, by your initial. Okay. All right, now, if I have outliers, say 119 and 124 is my outlier. Let me say it again. Forget what I just said earlier. The maximum, well, if I ask you what is the maximum of the data set, you still say 124. Right? So that's the largest number, the maximum, makes sense. But on the bar class, it'll be a different story. On the bar class is what you're gonna do. You don't have to write this down. I'll use blue. I'll use blue. So 124 and 1. So after, so you're still gonna use that 5-number summary to draw the Q1 and Q3. Same thing. So let me draw that Q1, Q3 here. And the median is gonna be exactly the same. Nothing changed. The only thing changed is that you're gonna have a outliers is 124 and 119. Maybe here. Yeah, maybe here. Okay. And then the minimum of 82. So, oh, sorry. So be still the same, 82. But you don't have this thing anymore. See that little, maybe I'll draw in cloud here. You don't have this. Does it make sense? So you don't see that. Let's cross it out. You don't have max, you don't have that.
What if only 124 was the outlier and 119 was still included?
So we go up there. So no, same. Let's see, 119 is still included. 109. So 1. Right now you also 120. It's kind of difficult this example because the numbers doesn't make sense. But I'll try my best. 119 is still included. It's the same, still the same. Then you're gonna have Q3. So because Q3 is right next to Q3, I think you're gonna have to do that for the max. It's the maximum in quotation. It's not a maximum, but because it's not part of the Q3, you still have to have something on it. But it's not outlier, so you cannot put a dot. Right? You cannot put hollow dot. So you can do it like that.
Okay, thanks.
So if you have an outlier below your acceptable range. So like if you had an outlier at 50, would that mean, would it look kind of the same way? Would you do it?
50,
where
we don't have
you
50 here.
I know, but just hypothetically, if you had an outlier that was lower.
Yeah, so let's say if we have outline, like we have, so the data set, you have 50, right? You have 50 here. So on the left side. So that means you're gonna change yours. So let me change it here, let me erase that. So the minimum now is what, 82? Oh, it's still minimum 82, but then you have a little dot below it. The reason why, does that make sense right now? Is that okay?
So the only time that you wouldn't put like a maximum or a
Mhm.
minimum line is
Because
if
it
both.
it coincides with Q3.
Okay, so if anything, if there's none that are above Q3 that aren't outliers, then you don't put a line.
Mhm.
Okay.
Yeah. The reason I give you an example that the kind of right, it's a short data. It's a short data set, so it's kind of clash with Q3. That's why you don't see that horizontal line above. But yeah, but someone say that if just 124 is outlier, then yeah, you have to show 119 as the line, as the maximum is. This score is not maximum, but does that make sense? Okay. Don't worry about too much. I'll promise you on the exam will be very straightforward. Just make sure you follow these steps. Okay. Show me your 5-number summary. Of course, you have to. That's part of the grade, right? Show me how you check your outliers and draw the box plots, and then make sure you don't forget the title. That. All right. Number 3. A farmer who sponsor a jack-o'-lantern carving contest supply a pumpkin for each of the contest participants. The participants are grounded a group based on experience and the size of pumpkin that they receive. The pumpkin that are provided weigh in average of 15 pounds with a standard deviation of 4 pounds. Provide interpretation of standard deviation of 4 pounds in the context. All right, someone tell me, how would you provide an interpretation of this?
The average weight of the pumpkin differs about 4 pounds away from its mean of 15 pounds.
Say it again.
The average weight of the pumpkin differs about 4 pounds away from its mean of 15 pounds.
Okay, let me write what you said. Okay, the average. Say it again. The average weight
of a pumpkin differs about 4 pounds away from its mean of 15 pounds.
A pumpkin is no G. Differs about. Don't write this down. About 4 pounds. Was it again 4 pound? What? 4 pounds
away from its mean of 15 pounds.
No. Somebody, it's a very, very classic mistake. But your sentence is almost perfect, except for something almost make it like almost perfect.
Oh, add standard deviation after 4 pounds.
No.
No.
Something wrong. Say, can anyone spot? Read it, and then it doesn't make sense to you. It's a very classic mistake. I'm glad you say it.
Do you have to include 4 pounds above or below?
No. I'm talking about standard deviation, not the z-score. Z-score, then I will ask you to do that. But no, we're not doing z-score, so we're okay. What this mean? What's average weight mean? That's the same thing as mean weight, right? So you say that the mean weight of the pumpkin is 4 standard deviation from the mean weight. So what is this? So you repeat it yourself. Can you see it now? You say the mean weight, which is 15 pounds, and you say the 15 pound is 4 standard deviation away from the 15 pounds. So that's what.
On average, instead of saying the average, on average, the weight.
Yeah, on average, right? On average, what? On average, comma, the weight, right, of the pumpkin, right? So let me, yeah, it's very important how you say it in statistic. It could mean different things. Excuse me. So on average, you can put on average in the front, in the beginning, or at the end, doesn't matter. On average, what? The weight of the pumpkin. Someone finish this for me.
Is 4 standard deviations away from their mean weight of 15.
Is approximately 4 pounds away from the mean weight of, or the mean weight 15 pounds. I don't want to hear standard deviation in the context. You don't have to. I know what 4 is, but I need units 4 pounds away. You can put the average right here, or you can put the average at the end, so that if somebody can say, somebody can say like the weight of the pumpkin is approximately 4 pounds away from the mean weight of 15 pounds, comma, on average, right? Or on average in the beginning. I usually do in the beginning, so I don't forget. I hope nobody, but thank you very much, whoever give me the first answer. That's what I want you to, I'm glad you showed me your mistake, so I can fix it, so you won't do it on the exam. If you don't say it, probably like half the class do it. If the extra large pumpkin are 15% of the pumpkin that weigh the most, how much must a pumpkin weigh to fall into the extra large category? So what they asking, what variable we solving? What they asking?
They're asking for X.
Yeah, they're asking for X, right? How much the weight, that's your X, right? So if I draw my normal curve here, and what is that? 15, so normal, mu is 15, standard deviation is 4. So mu 15 right here. 15% extra large, 50% of the pumpkin that weigh the most. So 15% is, so by the way, on the x-axis, that's weight, right? That's weight. Maybe I'll do in black. Weight, of course, in pounds, right? The further or to the right, the pumpkin weigh heavier, right? So the 15, so this is a 15% of the extra large pumpkin, right? And they ask you, what is X? Well, how much the pumpkin has to weigh in order to be in that category, 15% extra large, right? So in order to find X, what do I use? We did this before. What do I use?
X minus the mean over standard deviation equals Z score.
Yeah, so Z equal X minus mu divided by sigma. We have mu, we have sigma, but we don't have Z. So how do I find Z?
You can look at the Z table.
A Z table of what percentage? Or what percentile?
It would
85th
be
percentile.
Say it again?
15. Would it be for 0.15? You would
No,
look for the,
no. That's
I use 0.85.
why 0.85? Because these, how the nature of the Z score, they what? It's cumulative, right? From the left. Your Z table is always give you the percentage from the left. So up to that point from the left. So you have to look at the Z as 85%. So you want to look up at Z of 0.85. What you got? I'm gonna be lazy. I'm gonna use, I don't want to look at it.
1.03.
Okay. All right, I'm gonna double check, okay? One point, say it again, 1 point what?
03.
1.03, thank you. And then you plug it in, right? So 1.03 equal x minus 15 divided by 4, and then you solve for x. Don't forget your unit. I'm not gonna solve for it. You can do the math yourself, okay? It's not hard for now. Do you have any question here for A or B? C. Now it takes the time. Now it's different distribution now. Now they talk about the times, not the weight of the pumpkin anymore. The time to carve the pumpkin. So the time it takes participant to carve their pumpkin is uniformly distributed between 5 and 45 minutes. First of all, I want you to draw it and then make sure you label all the boxes here. So what's the distribution here? So how would I put in the distribution label?
There's 1 over A minus B.
Oh, so no, that's the y lay. I think you talk about y is as so this is uniform, right? Uniform what? Uniform A comma B. So what's A, what's B here?
Is it 5 and then 45?
45, that's your A and that's your B. Okay. Axis label, I'll tell you, just density. It's always density for all the uniform graph. What the probability density function, PDF? Yeah, PDF. Or the height. 1 over B minus A, so 1 over
40.
what the axis label?
Time.
And make sure you put what unit in minutes, right? Minutes. Okay, good. That's you're gonna see the exactly same thing on the exam. Well, not exactly problem, but some similar. So let's graph this. So it's from A to B. You can do as many as long as you want, or as short you want, as long as it look like a rectangle to me. So A is 5, B is 45. That's it, done. Done, yeah, done part I, right now, double I. Based on the model, what is the probability random selected participant will take more than half an hour to carve the pumpkin? So half an hour is how many minutes?
30.
30, right? So right here, 30 minutes. What shade should I shade to the right of 30 or to the left of 30?
The right.
Good, because more than half an hour, right? So I want to know what's the area that. Now, if somebody say, okay, so do you tell me what's the area under that curve? What the area highlight in blue?
Just do the width times the height.
Which is 1 over 40 times
15.
Say 45 minus 30. If you want to do all the math out, equal what? 45 minus 30 is 15 over 40 divided by 5, 3 over 8. You can give me decimal or just leave it like that. Doesn't matter. Now, I'm going to deduct 1 or 2 points. If you just leave, you just give me that. I need you to give me the notation as well. So remember the notation for probability of what? A random variable x is, well, does it be greater than or less than?
Greater than.
Greater than, right? So I need you to give me the notation as well. Very important that you know how to write things in notation. Because later is matters. So the probability that that somebody take more than 30 minutes to carve the pumpkin is 3/8. You don't have to give me decimal. I'll give you full point, just up to this point. It's not math class. I don't care. As long, but please reduce. Okay, if you have like 5/10, make sure you do 1/2. I don't want to leave it as 5/10 or 15/40, right? Reduce it. Okay, so one more thing. If I ask you what is the expected value of what is the expected time to call the pumpkin, say actual question, what would you say?
Would it be the average? So like 25?
Yeah, so it'll be what? It'll be you have to give me in notation as well. Notation, provide notation and symbol. What the notation for expected value?
EX or
Yeah.
mu.
Yeah, capital E, not a little e, but capital E of X, equal. So capital E of X is expected value is the same thing as population mean, equal. This is average. This is a uniform distribution. Each distribution has its own expected value formula. Okay, this is uniform, so it's A plus B over 2. And then you plug in the number. Okay, make sure don't forget units. So 25 minutes. Right? So this is just a little sideway. Okay, parameter or statistic? Census. Oh, parameter is what? What does that mean to be say parameter? What does it mean to be say statistics?
Does a parameter describe the population while statistic describes like the study or the sample of the study?
Yeah, it's a parameter is the units for population and statistics is unit for sample, right? So census is a parameter or statistic? You think about it. Let me do some line here. You think about it. You tell me. All right. Census is parameter or statistics? Do you guys know what census is? People, don't they send you email? They ask you to do census, say how many household in your family and whatnot. Remember that? It's mandatory, right? If you don't do it, they're gonna knock on your door until you finish it. So census is everybody have to do it. So what does that mean? If everybody then is
Perimeter?
yeah, it's perimeter census, right? Every 10 years we do census. Sample. Well, statistic, right? Mu.
Statistic?
No, mu. Parameter mu is Greek. Remember, it's something that the sound mysterious, like Greek letter, is gonna be parameter. It's gonna be population. X bar.
Statistic.
Yeah, that sample means statistic. Sigma.
Population.
Yeah, parameter, and then standard deviation. S. Sorry. Relation. No. S is length, right? Length is for sample, for statistic. Make sure you know these. Yeah, make sure you know these. Like someone said earlier, I forgot who I didn't take a look at the name. Parameter is the units for population. Parameter is not population, but it's rather is the unit for population. There's two different things. And statistic is the unit calculation for sample.
Professor,
Mhm.
I was just wondering, like for the 5-number summary, sometimes when I plug it in like on a calculator or like with Excel, it like
It's
to double
different.
check how it works.
It's different,
it's-
right? It's supposed to be different. Like I said, I think I mentioned this, have I? for hand calculating for five number summary is different than computer software. It's just how they use different algorithm. If you read the
Oh.
book, yeah, the textbook even say that. So it's
Okay.
okay. It's
So-
okay. Don't.
On the exam, if we decide to use a calculator, would that be okay, or would we have to do it by
No,
hand?
you have to do by hand. Because
Okay.
different answer. Mhm. But you can check. At least it's close, right? Close. Kind of close. You know what? For yeah, sometimes sometimes it's similar because if like odd number, maybe you get lucky and it's similar, but even number is always different. They use something different. I don't know what they use, but it's always different. Like even Google Sheet or R, they all different. All right, 10% of US senator voted for a particular measure, a perimeter or statistic.
Statistic.
Only 10%. How many senator do we have? No, in US. Not on the exam, just yeah, how much you know. How many senator do we have?
100.
Yeah, 100, right? So 10% will be 10 of them.
How
then
would
it-
you manipulate that one to make it a parameter?
Oh, just say just say US Senator, all US Senator voted for particular measure. If I just say all US Senator voted for particular measure, so it'll be parameter, yeah? All, right, all of them. We only have 100. Whenever you hit the word all, that's all that represent population. All right, identify which of the type sampling, simple random sample, convenience, or stratify. A, you think?
Is it SRS?
Good. Remember, it's a classic sample, simple random sample. It's just put a bunch of names in the hat, shake it up, and people pick. Okay? A student's council survey 100 students who by getting a random sample. Oh, we did this before. What is that?
Stratified.
Yeah, we did this before. Oh, somebody tell me what. Somebody just give me an example of convenience. I don't have it here, but somebody give me an example of convenience.
They walked down the hallway and chose the first 5 people they saw.
Yeah, that's it. Perfect. Thank you. Number 6.
Selection bias.
Why the selection bias?
Forgot my reasoning. 1 second.
Let double check. What definition? What definition of response bias? Say definition of response. Response bias mean what?
People lying,
People what?
like not telling the truth.
No, it's not what I meant. Is response bias is what when you voluntarily volunteer to respond something, right? To answer something. Sometimes it, yeah, answer something. Sometimes it could be under pressure. You lie about it, but because you're under pressure, or it could be word in effect. But mostly you volunteer to answer something. What about non-response bias? What's non-response bias definition?
When it's like harder to get people to respond or like reach them.
Yeah, when you are when you cannot reach the participant or they refuse to participate, right? So the non-response bias, like mail-in survey, definitely non-response bias, or phone call, right? Selection bias is what? When what?
They chose people only attending the football game.
Good. Why is that selection bias?
It's not representative of the general public.
Yeah, is everybody pay tax, not just people who go to the game, right? So you need to randomize you need to broad out your sample size because this is not right. More like ask by county, by county or by state, not by game. Yeah, everybody pay tax, not just people who go to the game. So selection bias. All right, number 7, and then we're gonna, let me see, well, you guys done it 4:47, but your quiz gonna be done at 4:45. I want you to have 20 minutes for the quiz, so at 4:25, we're gonna start. Yeah, 4:25, we're gonna start. Okay, let's finish this one. We take a little break and then we do the quiz. How much time do you spend studying statistics? Okay, let me highlight something here. So the actual study had didn't go from average 24 hours per week to about 15 hours based on a survey. Professor Sisek decided to ask his current semester students to report the number of hours per week they spent studying his course material. The resulting distribution was found to be approximately bell-shaped. The mean study time was 10 hours and standard deviation was 3.5. So the only number you use is this number, 10 hours for mean and 3.5 for standard deviation. Okay, the 24 hours and the 15 hours, that's the previous research, right? They changed now. Now it's 10 hours for the mean and standard deviation is 3.5. Julie is a current student and studies statistics for 6 hours per week. Calculate Julie's z-score. So Julie's z-score is, again, z equal x minus mu divided by sigma. How many how many hours she study per week? 6, right? Mean is 10. Standard deviation is 3.5. If I don't give you the graph, you don't have to graph. You feel free to do so. But if I don't give you the graph, it's not part of your grade. Okay? You can graph, maybe better for your visualization. 6 minus 10 is 4 divided by 3.5. What's 4 divided by 3.5? Don't leave it like that because there's a fraction and a decimal inside it.
Negative 1.14.
Yeah, negative. Why is it negative 1.14? Why is it
Because the
negative?
top number is negative.
Why is it negative? Why is Julie's z-score is negative?
Lower than the mean.
Yeah, she below the mean, right? She below the mean. So if you do the standardized curve, it's gonna be on the level 0. Okay, so that's Julie's z-score. Oh, it asked you to draw a sketch. So I asked you make you draw in it. So here, the box here, you just put an N. If you want to draw, I'm gonna draw the standardized curve. Okay, so if you mistakenly draw the raw curve, that's fine. I'll give you 4 points as well. But here I'm asking you to draw a standardized curve. So 0 here, that's 0 in the middle. What does the x-axis represent? This is standardized curve.
The hours studied.
No, this is standardized curve. It's not raw curve. Raw curve, then yes, that's time in hours. But this is because it's standardized curve. So what the x-axis represent? What do you put on the x-axis? What is that? Julie's, I'm sorry, Julie's z-score is negative 1.14. So I put negative 1.14 somewhere here. So what do you put on the x-axis? What are these?
The z values.
Z-score, right? So z-value will be your x-axis. Or z-score, doesn't matter. Z-value, z-score, same thing. Should I? Yeah. Then draw a sketch that represent the probability a randomly selected statistic student study less time than Julie does. So less than, so I'm gonna highlight the left tail. Because they ask you to highlight the somebody study less than Julie does. That's it, you're done. B, I'm sorry, not B, double I, use the Z table to calculate the corresponding probability. So Again, it's easy to look up, but you have to draw the notation. So probability of Z is less than negative 1.14. If you put equal to, that's fine. But you don't have that, it's fine also. You look it up, some number, right? But make sure you have this notation. Try to learn. It's gonna be a little bit challenging at first, but as we move on to next chapter, I'm gonna write a lot of those, and you get used to it. I'm gonna show you how to do this. I'll show you right now. Let me show you right now. Now your calculator will give you. So let me say to find the probability. You know, I don't have to say anything. I'll come back to it. Okay, I have it on the slide. I'll come back to you. It's in chapter 3 lecture, but it's not in the lecture. It's in the empty lecture, chapter 3, because I cannot change I wrote on it. I cannot change the lecture. Juan learned that he studied more than 70% of a college student. Based on the above distribution, Juan must study at least how many hours per week. Make a sketch of what you're trying to find to help you show your work. Okay, so 70%. He studied more than 70% of a college student. He studied more than 70% of college student. So from left to right, this is 70%. Juan is to the right tail, yeah? Because he studied more than 70%. So right here is Juan. I'll put X. This distribution is, okay, so let's do this. So what they asking again, what we did this before, what are they asking? They asking for what? What the final letter that we solve in here? X, right? Number of hours that Juan spent time studying statistics. So again, in order to find X, you use this formula always. And then in order to solve for X, you need mu, sigma, and Z, right? We have mu, we have sigma, but we don't have Z. So again, you have to look for Z score, or Z. Yeah, we have to look for Z score based on what percentile they give you. So what percentile do I have to look up here, to get Z score?
70%.
0.7.
Good, 0.7, right? If you do 30%, it's gonna be up like to here. That's 30%, and you don't want that. He studied more than 70% of the people, the student. So 70%. Somebody look it up. Tell me what it is. I feel like doing
The conservative z-score is 0.52.
0.52. Thank you. No, on the exam, if you pick like slightly or like conservative, I don't want to be too much difference, but if you, instead of picking the conservative, you pick the other one, it's fine, okay? But not like really far away from it, okay? Then it's not fine. Okay, and plug it in and you solve. 10 with a 10 and 3.5, yeah. And you solve for X. Make sure, don't forget hours. Don't forget units, okay? That's a point of your, part of the point. All right, let me show you how to do in calculator. Now, before I do this, the calculator it'll tell you from Z to probability, but it won't give you, you cannot find X like you did in Google Sheet or in R. Remember how I show you to find X in Google Sheet? You cannot do that in X. You cannot do that in calculator. Calculator will give you the Z, but from Z, you have to use this formula. Okay, so that's only the drawback, which is great because I want you to do by hand anyway. Okay, let's go to here, go to my chapter 3.
Do we have to write our notation?
Huh? Say it again.
Do we have to write our notation
notation for what?
for Juan?
No, it's just x equal whatever hours you solve for x. There's not asking for probability, they're asking for x, right? Is that what you're asking me?
Yeah.
Okay, you don't have to do P or something. It's not what they're asking. Only when they're asking for probability, then you have to do that. The P parentheses x greater than, less than, or z greater than, less than. Oh. Okay, I embedded some more slide here. It's in chapter 3, but it's not chapter 3 lecture note. That's I cannot change because I have handwriting on it. So right here is how to use calculator. All right, so first step is calculating probability. What you're gonna do is you're gonna press second and vars. The vars button is right below the arrow button, arrow down button. Second vars, and it'll get you to some sort of distribute. It gets you to distribution. Remember the DSR, the blue letter on top of your calculator. And from there, you're gonna choose normal CDF, cumulative density function. Cumulative, you want normal CDF. And press enter. After you press enter, you're gonna see something like this. Now the lower bound, put -99. Everybody put -99. You can put -10 if you want, any number really, as long as it's bigger than 10 or bigger than smaller than -10. But let's go ahead and put -99 and then comma and put in your z-score. Put in your z-score of Julie. Say Julie's z-score is -1.14. And comma 0, comma 1, and it will give you the probability. This example is not Julie's example, it's different example, okay? They have a z-score of -1.44. Our z-score is -1.14. So you should get let me do it. See what you guys have. Somebody say something. What do you have?
I got 0.127. And then a couple other numbers too.
Yeah, that's what I got. So there are roughly Julie got roughly 13%, right? So well, not Julie. Somebody studied less than Julie. The probability of somebody studied is 13%. Makes sense, right? Because remember, Julie area is tiny, right? That little tiny red on the left. So it'll be smaller than 50%.
Is this
Okay.
the same for a TI-84 plus? Because when I do that, it gives me like lower, upper, mu, sigma, and then pace.
Oh, you have the fancy one? Yeah, so if you're same thing, your lower, you're gonna put -99. Upper, you're gonna put -1.14. And then mu, you put 0, sigma, you put 1, and then paste. Is that what you have?
Yeah, now I got 0.127.
Yeah, that's the probability of someone studied less than Julie.
Okay.
So roughly what, 13%, huh? 12.7%, so 13%. Okay, so that's how, but yeah, the calculator doesn't have a lot. You have to calculate your z-score on your own, and then instead of look up on table, you can do on your calculator. Okay, now from probability to z-score. That's the only two things the calculator do. So from probability to z, this one, z critical value for the left tail test. What you're gonna do, same thing, second vars, but you're gonna go to number 3 instead of number 2. Second var, go to in norm, so inverse. Remember norm in Google Sheet. You're gonna enter in probability, well, typo there, probability. In norm is, probability is what? Let's go to Juan. Let's go to Juan, 70%, so 0.7. Don't put 70, put the decimal value. And then 0, then comma 0, comma 1. I got my z-score is 0.5244005. Is that what you get to? Is that what you have?
Yeah.
Okay, good. So that's your z-score. But then from there, you have to calculate x yourself. Does that make sense?
Yeah.
Yeah. Okay. Yeah, calculator is just not doing much. Just go from z-score to probability and probability to z-score. That's all. X you have to do yourself. All right. Let me say something before we take a little break. Now your exam, you can see up to like 80% of your exam from the practice, like similar question from the practice, maybe like 85%, something like that. Beside that, you have to really understand what you're looking for, not just the answer key. I will post answer key on Moodle, but you have to understand it, okay? Not memorize it. You will not pass the exam if you memorize it. And it's very difficult to cheat because it's not math. It's not something from equation that you can put in the app, right? It's all writing letter here. Okay, let's take a attendance and then